Hello and welcome all. Today we will look at the use of an inductor in an electronic circuit. Just we take an smps power controller where we can control the power using the inductor. How we will do that we will check now. Before that, in my earlier video of inductors, I have drawn a picture. I have drawn a picture of the flux from an inductor. Here the direction of the line of flux, here look at these directions. Direction of the line of flux is opposite to each other. This is coming in and this is coming out. Now inside the inductor, one is coming in and the next is coming out. If this happens, what will the result? The result will be one is coming in and the other is coming out. Then the two flux are cancelled each other and there will be no more inductance is left. So inductance means this will cancel out each other and the input voltage seems no inductance and heavy current flows through it and it will damage the coil. So the direction of the line of flux I have drawn is by mistake. It should be only in one direction. If it is coming here, this also have to be coming here, or otherwise if it is coming out, it has to be coming out. Here the current is flowing like this, then both should be coming out. Both should be coming out. Then only inductance, the property of inductance is really exists there. Now just look at the waveforms. This waveform is the waveform of an inductor with a low inductance. Low inductance means the number of turns is less, and this has the waveform of a high inductance. That means the inductor which has a more number of turns. Here the di by dt is high, and in this case it is low. How is this happening? As we know that when the switch is on, the inductor wants to oppose the 300 volt that is causing the flux to change. The property of the inductor is that it opposes any change in current. Here the current is changing due to this voltage. This voltage is adding more flux to it. So the inductor has to oppose it. It has to oppose 300 volt. If we take an example, how it is opposing, how the waveform comes. This waveform has more d5 by dt, that is more change, the slope is more. That is, in a particular time it reach the value of the flux is changed from 0 to a more value than this. The change is very less in a high inductance case than a low inductance case. How this is happening? Now we look at how the waveforms comes like that. That is, the low inductance waveform has a high d5 by dt and high inductance has low d5 by dt. How it is come? How the flux is changing more in low inductance and how the flux is not so much changing in high inductance. The case is that the input voltage is 300 volt. We have the inductor has to oppose this 300 volt, and the number of turns is for the low inductance is take it as 3 number of turns are there. What is the equation? The equation means voltage is equal to N into d phi by dt. What this means? This means that if the flux is changing in a second to a particular value, this flux is linked to all the turns. Whatever the turns available, this change in flux is linked to that. In this case, and a corresponding voltage is produced. We have to oppose 300 volt. So what we want is we have to oppose this 300 volt. And what we have in the low inductance case is number of turns is 3. Then we have to calculate what will be the d5 by dt. That is what will be the change in flux in 1 second that we have to calculate. So d5 by dt is equal to 300 volt divided by number of turns 3 is equal to 100. This is meaning that each coil is producing a voltage of 300. Then this 100 volt, this 100 volt into 3 becomes 300 volt, and now it is opposing the input voltage. Each coil is producing a voltage of 100 volt, and 3 coils are there. Thus, it is opposing 300 volt. For that, the change in flux should be more. To get a voltage of 100 volts per turn, the change in flux should be more. Whereas in this case, the number of the input voltage is what we have to oppose is 300 volt, and the number of turns is 6. And what should be the change in flux? The change in flux should be d5 by dt should be 300 volt divided by 6 is equal to 50 volt. That means each coil has to give a opposition of 50 volt. 50 into 6, 300 volt, thus giving a voltage of 300 volt. So the d5 by dt change in flux should be less in case of high inductance case. That is why the line of flux is low in the case of high inductance. That means there is more number of turns are there. More number of turns are there means the change in flux can be minimum. Each change in flux is linked to more number of turns, 6 number of turns. Then total becomes 300 volt. Here there is only three turns are there. So more voltage has to be occupied by each turns. Then 3 into 100 is 300. That is why d5 by dt is different in low inductance case and high inductance case. So thus by increasing or decreasing the number of turns, we can increase or decrease the inductance, and thereby we can control the power that is coming from the input voltage and storing in the core. That is, by increasing the number of turns, we can reduce the flux that is stored in the inductor, and thus the output power can be minimized. Or if we put a low value, less number of turns, the inductance is low, so more flux can be stored in with a little time, and more power can be delivered to the output. This is the one use of the inductor in electronic circuits.